In this episode, we are going to solve some problems on continuous motion under rectilinear kinematics. So we have some problems that we have to look for. Let's start. Example 1. The position of a particle along a straight line is given us. So we have the function x 1.5, that order. It is in terms of feet, where t is in terms of seconds. Now, we are to determine the position of the particle when t is equal to x, 6x, that means 6 seconds, and the total distance it traveled during the 6 seconds interval. Now, there's a hint here that we should plot the paths to determine the total distance traveled. Are we okay? So, straight away, let's get into the action of solving. So, writing down our parameters, we have the position of the particle as a function, which is 1.5 minus 13.5 t squared plus 22.5 t in terms of feet. We are evaluating this at time 6, and we are looking at finding the position of the particle at time 6, and also we are looking at the total distance. The x is just the distance or the position given, and we are looking for the total in the 6 seconds, and we are to evaluate the position, which is the position function is this. Find the position at 6 seconds. So meaning put in the value of the 6 in the position expression, and that will give you the specific position of the particle at the point 6. Is it clear? But the total distance is referring to the total distance is traveling from the 0 up to that 6 seconds. But the determining of the position is just the point at which it is at the 6 seconds. Alright, so the first part is that we want the position at time 6. So that is going to be 1.56 cubed minus 13.56 square plus 22.56, and the position at 6 is going to be negative 27 feet. In the previous episode, we saw that the position can be in the negative or the positive, depending. If it is moving to the positive side, it is going to be positive. It is negative in this direction. Are we okay? So it is at a position negative 27 feet from the origin. So with the coordinates, you'll be able to know where it is located. Now we are to determine the total distance it traveled during the 6 seconds interval, meaning from 0 second to the 6 seconds. What is the total distance it has traveled? So from 0 to 1 to 2 to 3 to 4 to 5 to 6, we are going to see what happened in that place. So B. So here what we are going to do is very simple. We are going to look at it from 0 to what? 6 seconds. And first, if you want to know where the particle is going to turn, right? If you want to know where the particle is going to turn, we must find the velocity and equate it to 0, because at the turning point of a particle, the velocity is going to be 0. So from the distance expression, then we are going to say our velocity v, which we know is the derivative of this function, is going to be, now let's differentiate the x function. That is going to be, I'm doing it straightforward, that is going to be 4.5 t squared minus 27t plus 22.5. So we are saying at the turning point. So we are going to look at the point at which the particle is going to turn. Then V is equal to 0. So if I equate this thing to 0, which is going to be 4.5 t squared minus 27t plus 22.5 equal to 0. This is a quadratic equation. When you solve, you are going to get your t is equal to 1 and your t is equal to 5. So 1 second and 5 seconds, there was a turning of the particle. Are we good? So meaning now we are going to look at, let me see, from 0 to 1 second, to 5 seconds, and to 6. This will, if we do the analysis this way, it will help us to know, because at 1 second it turned, at 5 it is going to turn, and we're also going to look at its final destination at the 6 and its initial destination from the 0. So let's look at the position of the particle at x is equal to 0. So if x is equal to 0, the position means put the 0 inside the position expression and find it. So that is going to be 1.5 by 0 cubed minus 13.5 0 squared plus 22.5 by 0. So at time 0, it is at 0 meters. So it hasn't moved. It is at the origin. Are we good? So let's also look at the other time intervals where it is going to be. So we are seeing that at x is equal to 0, it is 0. Let's look at x is equal to 1. Where is the particle? So at 1 means we are going to put in 1.5 by 1 cube minus 13.5 by 1 square plus 22.5 by 1. And this is going to give us, it will be at a position 10.5 feet. We also saw that there will be a turning at 5 seconds. So at 5, that is going to be 1.5 by 5 cube minus 13.5 by 5 square plus 22.5 at 5, which is going to give me negative 37.5 feet. So do you see that the distance is changing? The position is changing, meaning there was a turning point at 1 and 5. Alright, so let's look at the final time. So at the final time, x at 6, where was the position? And we did that for the first part. When we saw for x equal to 6, we saw that the answer was negative 27 feet. There was a hint that we should plot the motion to be able to deduce it. So now look at this. If we are plotting, because there is positive and negative, let's start from here. So this is going to be it, our origin. And at x is equal to 0, t was equal to what? 0. So the particle is starting from here. At time 0, the particle is here at the origin. After 1 second, we saw that the particle had moved to 10.5 feet, which is 10.5. So this is s in terms of what? Feet. It has moved to this point. So the particle has moved up to this point. Now, after the 5 seconds, because after the 10, we saw that it is turning. There was a turning here. So it turned, and after 5 seconds, it is at negative 37. So meaning it will be here, negative 37.5. So it is going to turn and come back to this point. So at 5 seconds, it is here again. And we saw that there was a turning again at the 5. And at 6, it is at negative 27. So negative 27. And the particle came to this part. So we can see the motion as A to B, B to C, and to D. Very good. And we are to find the total movement. If we are to find the total movement, that is going to be movement from, since we are interested in position, we can take the magnitude of the motion, A to B, then we add it to B to C, then we add it to magnitude of C to D, right? Okay, so this is going to be, now from A, it is going to be, it was 0 minus up to B. We are saying minus because we want to find the difference so that we will know where it is, right? This is position from here to that. So to B at 1, that is 10.5, plus at B, so we are now looking for the difference between this and this 2, that is 10.5, minus at C, which is 5, it was another negative 37.5. Is that true? Yes. So at C, it is going to be negative 37.5, minus at D, it is also minus 27 this way. Are we good? Alright, so now you will see that this is going to be negative 10, but the magnitude will give us 10.5, plus this will be addition, which is 48. This is also going to give us, plus it is going to be negative 10, but the magnitude is going to be 10.5. And if we solve for the total, that is going to give us 69 feet. So the total distance by the particle is 69 feet. Are we good? So this is the final answer for the total distance. Quite simple. Let's look at the example 2. Example 2 is also given this way. Now, the velocity of a particle traveling in a straight line, we are still talking about continuous motion. V is given by this, where t is in seconds. If at x is equal to 0, which is the origin, the time was 0, meaning at time 0, the particle had not moved. Determine the particle's deceleration and position when t is what? 3 seconds. We are also interested in how far, so let's first solve the first part. With the parameters, I'm going to have my v function to be 60 minus 3t squared. Are we good? I'm interested in deceleration, which is the negative of acceleration. So we are looking for this, and I'll also look for position x at time what? 3. So just as we know, acceleration is, or deceleration is simple to see. I'm representing the deceleration by A because it is the negative of acceleration, and it will come, we will see. So which is dv on dt. So meaning I'm going to differentiate the function 60 minus 3t squared with respect to what? Time. And this is going to be equal to, if you differentiate this, you are getting 6 minus 6t. So the acceleration function for the motion is 6 minus 6t. And when the t is equal to, we are interested in t at 3 seconds, then a is going to be 6 minus 6 by 3, which is going to be 6 minus 18, and that is going to be negative 12 meter per second square. So we can see that it's negative form of acceleration. That's why we are calculating for deceleration. Are we good? And we have to find the position 2 at this time. Position means we are going to integrate the velocity function, right? You can pause the video and try that. So v is equal to dx on dt, which implies that my dx is going to be v dt. The dt is coming because the function of v is in terms of t, so that is going to be integral of dx from 0 to x, from 0 to a certain t, and our v is 6t minus 3t squared, or dt. This is going to give us x, and if we integrate this part, we are going to have 6t squared on 2 minus 3 on 3t cubed. The integral has limits of 0 to t. So finally, my x is going to be 3t squared minus t cubed from 0. Now the t we are evaluating at is at 3. So my x, so if you put in the 0, all will run to 0. So we will just put in the upper one, which is 3 by 3 squared minus 3 by 3 cubed. And that is going to be 0. So meaning at 3 seconds, the particle is what? At 0. Remember, at t is equal to 0, x is equal to 0. So at t is equal to 3, x is also 0. Meaning the particle has gone to a place and returned back. We don't know yet. Right. Yes, it has gone and returned to its position. Or it has gone from 0 and to the negative directions and returned to its position. Okay, so you can go back and look for it like this. All right. So let's continue from this part. We have seen what we are looking for. We will draw the motion so that we will get the understanding. So first, let's look for the turning point, and we know that at the turning point, so that we'll see if it went to the negative or the positive direction. So at the turning point, v is equal to 0, and the v function was given as 6t minus 3t squared, right, equal to 0. So this means 3t squared is equal to 6t. Now 3t is equal to 6, which implies that my t is 6 on 3, which is 2 seconds, right? Meaning it is going to turn at 2 seconds. So if I draw my line with my origin here, my 2 seconds is going to be this way. So at the first point, t equal to 0, it was here. Then the particle started to move this way and turned at 2 seconds. Then after 3 seconds, it is back to this position. Is that true? Yes, that is true. So let's look at the distance it traveled at the 2. So from the s function, we are going to put in the 2. Now the s function is also given us, we just use it as 3t squared minus t cubed, which is 3 by 2 squared and minus 2 cubed. That is going to be 4. So at 2, it has traveled 4 meters. 4 meters this way. Very good. It has traveled 4 meters. And we are looking for the total time. If it traveled 4 meters here and traveled 4 meters back, then what is the total time or the total distance traveled? Therefore, the total distance traveled from the question is going to be 4 plus 4 meters. And that is going to be our 8 meters. So this is the total time or total distance it traveled. And the question was also interested in finding the average speed. Remember, average speed is just total distance over total time. And now we've seen that our total distance covered was 8 and the total time was 3 seconds. So the average speed, which is the average velocity, is going to be 2.7 meter per second. And this is for this episode. Thank you for watching this episode. Please subscribe to the channel, like the videos, and drop your comments. See you in the next episode for a different form of motion that we are going to discuss.